Hello dears, here we will continue with the root locus in the last material of this module. Here we will start with angle of departure and arrival for a complex pole, which means if we have on S plan there is a pole which complex pole, and this pole is we are going to draw the root locus for this pole, means the pole is going to move toward the zero. At what point, at what angle the line will start? Because if you notice here, this is the axis, so the line will start from anywhere on this 360 degree. So when it's going to start, let us say it start at angle 120. That means here it's going to start. The root locus will start this way, then it will take its direction toward the actual root locus. If let's say we are having 0. 0 means we are going to get arrival, not departure, arrival. Let's say the arrival is, for example, 90 degree. That means here we are going to start. The line will reach to here. Where is it coming from? Wherever. It's coming from 0, wherever, from pole. Wherever that pole, but once it reach to the 0, it will enter the 0 at angle of 90 degree. This is going to be clear after a while, but I want you to get very small idea about angle of arrival and departure, and later we will calculate and we will draw to get ourselves clear about it. Now, how am I going to get the angle of departure and arrival? He's saying any point on S plan, any point on S plan, it's going to be on root locus if it satisfies this equation. Any point on S plan, it's going to be on root locus if it satisfies this equation. Let us see what does it mean in the next slide. So from here we are going to get clear about the calculation of the angle or the meaning of the previous equation. He's saying, let us say this point is in root locus. If it's in root locus, it's going to satisfy the equation given earlier. So how it's going to be satisfying it, or what does it mean? How to write the equation? The equation is going to be written as the angle of zeros minus the angle of poles equal to 2k plus 1 into 180. What does it mean again? Also, what does it mean? Let's go to angle theta 1. Theta 1, it's the angle of this pole toward that point, which this angle. So we are going to say, right, minus theta 1. How about theta 2? Theta 2 is this point, this one. What is the angle of theta 2? The angle of theta 2 is going to be starting from here up to this point. Then that's the direction toward this point. Now, what to put the angle of the theta 2 is supposed to be plus, because we said angle of zeros minus the angle of poles. Let's go to theta 3. Theta 3 is this angle. If you notice here, it's 0. If it's 0 means it's plus. So it's going to be the angle is starting from here. So you notice how we start the angle. Always we start the angle from the origin and rotate until we meet the point, meet the angle. So here we start from this origin and we move until here. This is theta 3. And it's, what to say, its value is equal to plus theta 3. Guys, what do I mean by the angle? If I want to draw these angles, simply I will say we are going to connect all the lines together. All the lines to that point, all the lines to the point which we are expecting to be on root locus. What I mean by those lines, it's the line from 0 to the point, pole to the point, 0 to the point, this pole to the point, this pole to the point, this pole, 0 to the point. So those lines which I draw just now, what angle they are taken? If I start by this one for theta 2, it's going to take this angle. We are already clear about positive and negative. If I take about, for example, theta 6, it takes this angle. If I talk about theta 4, it takes this angle. How about theta 1? It takes this angle. So always we are going to consider these are the axes and this is angle 0. And from here we will rotate until we meet the point. Okay, that's how we can get the angle. In the next slide, we are going to see equation. I make equation in a simpler way. You will see it in the next slide. So here are the angles I mentioned. I explained them on the figure just now. But if I want to calculate the angle of departure and the angle of arrival, remember, angle of departure, it's the angle for the pole to start its root locus. So here we are going to calculate theta 1, for example. It's either theta 1 or theta 4 or theta 5. These are the angle which is going to be departure or have departure. So when we'll calculate it, it's going to be theta 1 equal to theta 2 plus theta 3. I mean that the angle of zeros minus the angle of poles, all minus 2k plus 1 into 180. Or even we can write the equation in much easier way. What is that way? Which shown here, this one. So the angle is written here clearly as angle of departure is to be calculated as the summation of the angle of zeros minus the summation of the angles of pole, all plus 180. So departure means 0 minus pole plus 180, which means angle of 0 minus angle of pole plus 180. Now, if I go to the other one, which the angle of arrival, we will see it in the next slide. Of course, here it's explained. It's the same way as before. So angle of arrival, we can calculate from this equation, which is similar to the previous one, or the one which I said it's easier. So angle of arrival going to be given as angle of poles minus angle of zeros plus 180. Okay, let us do this example to get clearer about angle of departure and angle of arrival. In this example, he asked us to plot the root locus and calculate the angle of arrival and departure. Of course, first thing we are going to identify the poles and the zeros. So we have here 0 at -2, pole at 3, and two other poles. They are in complex quantity. Here we found them. We found that there is one of them at -1 plus J1 and the other at -1 minus J1. I mean minus plus J1 for both of them. We will see in the next slide their location. So, and here is the location. We have one pole at -3, pole at 1 -1 plus J1, and the other one at -1 minus J1. Beside that, there is a 0 here. Now, we will start by calculating the angle of departure and angle of arrival, if any. Of course, he will not mention. We must know. Now, if I want to calculate, I will calculate, of course, for the pole. So if it's for a pole, means it's angle of departure. If it's for a pole, means angle of departure. Now, for this angle of departure, to evaluate it, we need to connect line between all the elements, all the poles and zeros toward this pole. That's going to result in three angles: theta 2, theta 3, and theta 4. So we are going to find the value for these angles, and we will put them in the equation mentioned earlier to calculate theta 1, which is the angle of departure. Now, the equation is given here, this equation, which can be written as minus theta 1. Theta 1 is the angle which we need to calculate. Minus theta 2 plus theta 4 minus theta 4, plus theta 3 minus theta 4 is equal to 2k plus 1 into 180, k equal to 0, so it's equal to 180. So to avoid confusion, always we are going to take it this way. Okay, if I want to calculate, let's take this one inside, take this 180 inside, and take this theta 1 outside to put the equation in the right form. It's going to be, or we can write it as theta 1 equal to minus theta 2 plus theta 3 minus theta 4 minus 180. Now we need to put the values here. What is the value of theta 2? Let us go to theta 2 now. Theta 2 is this angle. It's very clear that it's 90. It's very clear that it's 90. So we will put as minus 90. Now let's go to theta 3. Where is theta 3? Theta 3, notice it's positive. Theta 3 is this angle. How to evaluate it? It's not given, but we can calculate it as tan inverse of this side over this side. That means tan inverse of 1 over 1. We will calculate it tan inverse of 1 over 1. We will find that it's equal to 45. And again, it's positive in sign. The last one is going to be theta 4. Theta 4 is this angle. How to calculate it? It's tan inverse of this side over this side, where this side equal to 1 and this side equal to 2. That means tan inverse of 1 over 2, which shown here. So it's going to give me the value of a 26, and the sign is negative. All minus 180. So we will solve them all. We are going to find that the angle theta 1 is equal to 108.4. That's theta 1. That's theta 1, which means the angle of this pole toward infinity. How about the angle of this pole? It's going to be minus 108.4. Minus 108.4. So for theta 1 toward infinity, it's equal to this much. For theta 2 toward infinity, not toward theta 1, keep in your mind, toward infinity, it's equal to minus 108.4. That's how we can calculate the angles. Now, once we get the angles, we will start the drawing. To draw it, we are going to start with real axis segment. So this line is to be drawn from pole to 0. That means the direction is this way. Now for this pole and this pole, they don't have zeros on S-plan. That's why they will go to infinity. And they will go to infinity ultimately with angle of 90 and angle of minus 90. But we will start at angle 108 and minus 108. So we start here 108, and then we will make around toward the 90 degree, and we will continue. Same thing here. We are going to start at 108, and we are going to make around, and finally is going to go with 90 degree. So when I say the angle of asymptotes is 90 degree, so we will start at 108, and as we are approaching infinity, the angle will be 90 degree. So the red color is the root locus right now. Let me just remove this one and this one. Finish. So now this is what you can see here in red is the root locus of that function. Another example here, which will ask us to do many things. So in this example, he gave the transfer function, and he asked us to sketch the root locus. Remember, root locus can be sketched without any calculation. I mean, in approximate way. And later we can calculate the quantities, or we can calculate the quantities and draw it more accurate. So either one is okay, no problem. So he's asking me to sketch the root locus, then find the j omega crossing, calculate the value of k for j omega crossing, find the angle of arrival and departure, and find the break-in point. First of all, we will locate the poles and the zeros. There are two poles. This is one pole, and this is the other pole. And 1, 0 at minus 2, it's this one. Now, when I want to draw, guys, start with the real axis segment. Real axis segment, we said to the left of odd number of elements, there must be a line. That means here there is a line. Now, we said also, according to the rules of root locus, the pole on S-plan will meet the zeros on S-plan. And if there is difference in the number of poles and zeros, the rest of poles or zeros will go to infinity or come from infinity. What do I mean here? We have here two poles and 1, 0. According to that rule, one of these poles will meet this 0. Finish. But how about the other one? It's going to go to infinity. Here, I need to go with certain lines satisfying the other rules of root locus. What are the other rules? We have to keep the symmetry. The drawing is supposed to be symmetrical. So if it's symmetrical, we are going to take this point until here, and it's going to continue its way toward infinity. So it's going to go with this direction and this direction. And for the other one here, is going to go this way, this way, this way, then it's going to go to the pole, to the zero, sorry. So that's how we satisfy all the rules of root locus. Or maybe somebody will get confused. How am I going to get? I'm still not clear about doing this one. If you cannot draw it now, wait until you calculate the quantities. Calculate the j omega crossing. If you find that there is j omega crossing this point, that means you are going to go this way. And you will continue with the locus. Also here there is a j omega crossing. You will go this way and you will continue. Continue until where? Until the break in. So you will calculate the break in. Once you find the break in, that means you are going to go toward it. Now when the two poles reach to the break in, one of them will go to the zero and the other will go to the infinity, to the zero and infinity. That's how we can draw the root locus for this kind of pole plot. Let us continue now with the other quantities required. To find the j omega crossing, we will find the closed loop transfer function from using this equation, and we will come out with the characteristic equation. From the characteristic equation, we will arrange it as you see here. Then we are going to use Routh-Harwitz table to find the value of K for, the range of K for keeping the system stable. So here is the Routh-Harwitz table. From the table, you will find that this is the row of zeros, or which is supposed to be a row of zeros once we reach to j omega. When I reach to j omega axis, this row will be 0. So what is the value of K which will make a row of zeros? The value of K which will make a row of zeros, there will be a row of zeros if K equal to 4, as you see here. Because 4 minus 4 equal to 0, so I will get a row of zeros. That means K is the value which will send us to the j omega. It's not the value on j omega. No, it will take us to j omega. Finish. I know the gain, the value of K, the gain. How to identify the value of j omega? How to calculate j omega? To calculate j omega, we are going to take this 4 and we will put it in the previous row and build or write the polynomial out of that row. So it means here we are going to get 1 square plus 13 plus 2 into K. That means 2 into 4, which means 8. That means here it's going to be 13 plus 8. Now it's equal to 21, which means now I can write now the equation or the polynomial. It's equal to s squared plus 21 equal to 0. Now find the value of s here. You are going to find that s, which equal to j omega, it's equal to plus minus j 4.58. That means this point is equal to 4.58. Remember, the point on j omega equal to 4.58. But to reach it, the gain must be equal to 4. Now to evaluate the angle of departure for the two poles, angle of departure means, if I put the axis here, I mean this angle, the angle we start. And here is the same thing, the angle we start. Then after that, we are going to get help from j omega to know to what direction we are going to go. How to get it? Of course, he's assuming that there is, not assuming, he's putting here a pole, and here is a 0. So when I want to start calculation, I will connect all the other elements toward the point of calculation. That's going to result in angle here and angle here. We are going to take these two angles to write the equation mentioned earlier. So how to write the equation? I will come to this point. It's this one. It's equal to minus theta 2 plus theta 3 minus 180. That's the angle of departure. So the angle is equal to, we are going to write it as the angle of, poles, angle of poles minus angle of zeros minus angle of poles, angle of zeros minus angle of poles. So theta 1 equal to angle of zeros minus angle of pole minus 180. What are the angle of zero? We have the angle of zero is this one, and the pole is this one. You can write either one first, no problem. So for the angle of zero, it's equal to tan inverse of 3 over 4. Why? Because this element, this size is equal to 3, and this size equal to 4. This is equal to 3, you see? I'm talking about this one here. It's clearer here. So between this point to this point, it's a 3 elements, it's 3 steps. Between here to here, it's 4, because here 2 and here another 2. So it's 4. So 3 over 4 minus the angle of pole is 90, is clear. Okay, minus 180. So when we calculate it, you will find the angle equal to 126. The angle for this one to travel is 126. For the upper one is 126. So I will calculate 126. This is the angle. And for the other one is going to be minus 126. This is 126, something like this, and this is minus 126. So how this can help me? It can help me only to start. Then after that, I will take other way. Only to start at that position, then I will go other way toward my drawing. So as you see here in the figure, this helped me only to start. Then we will make the turn toward the j omega, because the first help to me is the j omega, then the break-in. The break-in and breakaway, of course, here we are having a break-in, not a breakaway. We said break-in because the lines, the root locus is coming to the real axis. So if I want to calculate the break-in, he is using this method. The summation of 1 over sigma plus z1 is equal to the summation of 1 over sigma plus p1. So it's equal here to 1 over sigma plus 2 equal to 1 over sigma minus 2 plus j3 plus 1 over sigma minus 2 minus j3. Remember, these are the poles, and this is the 0. I mean, from here we are taking the pole, and from here we are taking the 0. Now, solve sigma from this equation. Use this equation to solve sigma. Finally, you are going to find that the equation can be simplified to be s squared plus 6 sigma minus 21 equal to 0. From there, we are going to find two values for sigma. I remember sigma is s. One of them is minus 7. The other is a 3. Of course, the poles are starting from here, going to this point, then they will continue. So it's going to go to minus 7. A 3 cannot be. A 3 cannot be. So 3 cannot be. That means the value is minus 7. That's all about the root locus. I hope you are clear about it and you know how to draw it. So we will stop here. Thank you very much.